Students, in last video lecture we have discussed electromagnetic spectrum, and similarly we just have discussed the bands within which the frequencies or wavelength of the optical fiber cable will be chosen. Uh, and similarly, we just have discussed the wavelength range of this optical fiber cable as per your textbooks. So here in that electromagnetic spectrum, the wavelength range of this optical fiber cable is from 800 to 2550 nanometers. And according to your textbooks, we don't discuss those optical fiber cables, but we discuss those optical fiber cables whose wavelength range is 800 to 1600 nanometers. And similarly, so during then only we just have discussed that for this optical fiber cables, we choose these frequencies or wavelengths from the top three bands because of the higher frequencies that these top three bands are being holding when compared to the bottom six bands. So in the electromagnetic spectrum, we got 6 plus 3, 9 bands are there. Therefore, top three bands are very important for us for describing the frequencies of this optical fiber cable. And so I said that we just choose a minute portion of visible and near infrared regions for describing the frequencies of this optical fiber cable. So in the infrared, two regions have been existing. One is said to be near infrared, other one is said to be far infrared. This near infrared is close to the visible, and similarly far infrared is far from the visible, but we could say that this far infrared is close to the microwaves, I can see. Therefore, far infrared we are not choosing, but we are choosing this near infrared only. And so among these three bands, one band is said to be the band which has got longer wavelengths, other band is said to be the band which has got a shorter wavelengths. So for the longer wavelengths, frequency will be less, whereas for the shorter wavelengths, frequency is high. So this is what the topic that we discussed in the last class, and now in this class we move on to something important topic to your external to your external exam to your external exam. So that is to be the elements of optical fiber communication system, you can say. So you could have got some awareness regarding the block diagram of a conventional communication system. Therefore, in that block diagram, we know that we a total of three blocks are going to exist in that block diagram. So the first block is said to be the transmitter. Second block is that communication channel, and third block is said to be the receiver. So this is what the block diagram that you could have discussed earlier, so that you can take this the analog communication. Else you can also take this digital communication system. So in those communication systems, this is said to be the the conventional communication system block diagram that you people could have studied. So the first block here is said to be the dotted portion I have shown, and this dotted portion indicates the general communication system. Therefore, in this dotted portion or dotted box, three elements I have shown. So the first element is said to be transmitter, second element is the transmission medium, and third element is said to be the receiver. Therefore, in the transmitter and receiver, this frequency translation operation is going to take place, whereas this transmission medium is going to carry the signals from the transmitter to the receiver, or it is going to carry the signals from the source to the destination. So probably in any of the communication system, we don't show the presence of source and destination. However, these are going to exist in the communication system here. And so here I said that in the transmitter and receiver, we do some frequency translation operations. So the frequency translation operation that will be done in the transmitter is said to be the modulation, and similarly in the receiving end, reverse frequency translation operation will be done, and that is said to be demodulation. So modulation is something, an operation that is going to shift the low frequencies onto the high frequencies. So low frequency signal is there, and that low frequency signal will be shifted to the high frequency signal. And similarly, at the receiving end, demodulation takes place, and that demodulation is going to do the reverse operation. It just shifts back the high frequencies into the low frequencies. So the reason of doing this modulation in the transmitting end and at the receiving end, we do demodulation. So the reason is so it is not possible to transmit these low frequency signals far away. Therefore, for that sake only we just do this modulation, or we just do this conversion. What conversion we are doing? We are converting the low frequency signals into the high frequency signals. So those low frequency signals might be the plain text, it might be the voice signal, it might be the music signal, it might be the video signal. So in order to transmit these information, or in order to transmit all these low frequencies, we do this modulation. And similarly, the output from this modulator or transmitter is said to be an electrical signal whose frequency is very high when compared to the signal at the input of this modulator. And at the receiving end, we do the reverse operation. So input to this receiver is said to be an electrical signal whose frequency is high, and the output from this receiver is said to be the low frequency signal. So the output of this receiver is same as the input from this information source, I can say. So what I mean to say is the signal that this information source is generating should be same as the information that this destination is going to receive. So we know that in this transmitter and receiver we do various signal processing operations, and those signal processing operations right now is not important. Therefore, you just remember the concept of the general communication system. So this is what the concept of the optical fiber communication system. So we are not finding much difference between this general communication system block diagram and optical fiber communication system block diagram. Only the difference is this electrical transmit and optical source. This is said to be the transmitter section, or the transmitting section in the case of optical fiber communication system. And similarly, when the receiving and the receiving side, we just have got one more combination, that is said to be uh, optical source followed by the electrical receive. So ఈ బ్లాక్ ఉంది కదా, ఈ బ్లాక్ వచ్చేసి మీకు ట్రాన్స్మిటింగ్ సెక్షన్లో వచ్చేస్తుంది, ఈ బ్లాక్ వచ్చేసి మీకు రిసీవింగ్ సెక్షన్లో వస్తుంది. కాబట్టి ఆప్టికల్ సోర్స్ ఎలక్ట్రికల్ ట్రాన్స్మిట్, ఆప్టికల్ ట్రాన్స్మిటర్ అయిపోతుంది, ఆప్టికల్ డిటెక్టర్ electrical receive, optical receiver అయిపోతుందండి. So that is the only difference between the communication system or general communication system block diagram and optical fiber communication system block diagram. But you should know the purpose of using this electrical transmit, optical source, optical detector and electrical receiver. I said that these two forms optical transmitter, these two forms optical receiver here. So I said somewhere I said that in the case of optical fiber communication system, we do this modulation, and so modulation we do, and similarly we do this demodulation. So generally we just use one distant modulation technique in order to transmit the information from the source to the destination, and that distant modulation technique that we use here is said to be amplitude shift keying. So this concept will come in unit 4. During then, we'll just discuss the concept of amplitude shift keying a bit deeper there. I know that you could have got this amplitude shift keying earlier in the communication systems only. And so look, electrical transmit is that this is said to be the drive circuit to this optical source. And similarly, so to this optical detector, the drive circuitry is said to be electrical receive. So this electrical transmit is going to receive the low frequency signals from the source, and it is going to convert that into the high frequency electrical signals. Therefore, it is clear that this is doing that conversion. Low frequency signals will be converted into high frequency signals, and it is not possible to launch these high frequency electrical signals into the optical fiber cable because this optical fiber cable is been designed for carrying light pulses or optical signals only. Therefore, high frequency electrical signal is not the optical pulse or light pulse, I can say. And therefore, you need to convert that high frequency signal into a form which is compatible to the optical fiber cable. Therefore, that conversion will be done by this optical source. So here, high frequency signal will come. This high frequency signal is in the electrical form, and I had to convert that electrical form into the optical form so that I can able to launch that signal into the optical fiber cable. Therefore, we just use this optical source block. Optical source block, what it does is it is going to convert these electrical signals into the optical signal. It means that this is going to act as a converter, and that converter is to be electrical to optical converter. In short, we can call that as EOC only. EOC stands for electrical to optical converter. So we can use any of the optical devices as the optical source here. So either we can use this LED, else we can also use this laser. LED stands for light emitting diode, and the laser stands for light amplification by stimulated emission of radiation. So one is going to produce these photons or light pulses through spontaneous emission process. Other one is going to produce photons uh, as the output through stimulated emission process. If you are using this light emitting diode, then in that case photons will come out through this spontaneous emission process. If at all you are using this laser, then photons will come out through stimulated emission process. And I know that you have got this concept in engineering physics. If at all you have not got this concept, then again in optical sources, we discuss each of this optical source deeper. Therefore, I said that in this optical source, either we can use this LED, else we can also use this laser. So if at all you are using this laser, then in that case, we need to use that optical source which has got a lesser core diameter. So here we just have got single mode optical fiber cables and multi-mode optical fibers as the category to this optical fiber cable. Therefore, to this optical fiber cable, I said that if at all you are using this laser, then in that case we need to use that optical source which has got lesser core diameter. So it means that we can use the single mode optical fiber cables because these single mode optical fiber cables have got lesser core diameter when compared to multi-mode optical fiber cables. And now, if you think that LED you are using, then in that case you have to use this multi-mode optical fiber cables because this has got more core diameter when compared to the single mode optical fiber cables. So for time being, you remember that either we can use this single mode optical fiber cables, else we can also use this multi-mode optical fiber cables depending on the type of source that we use in the optical source block. And after this, the first block in the optical receiver section is said to be optical detector. So again, this optical detector is also a transducer, just like this optical source. I said that this optical source is doing a conversion, and that conversion is said to be electrical to optical conversion. This is doing, then we just call that as a transducer. And here, this optical detector is there. Even this optical detector does a similar conversion, but not electrical to optical, but instead it just converts this optical signals into electrical signals. It means that this is said to be the reverse transducer or inverse transducer of the optical source, I can say. Uh, Therefore, we can call this as a converter, and that converter is said to be OEC. OEC stands for optical to electrical converter. So here in the optical fiber communication system, we just take only two photo detectors or optical detectors here. So either you can take this pin, if not pin, you can also take this APD. So this pin stands for positive intrinsic negative, and APD stands for avalanche photodiode. So in the pin, you don't find higher gain, and similarly you don't find any amplification of incoming photons from the optical fiber cables. Photons will not get amplified if at all we are using pin diode in the optical detector. And similarly, so if you use this APD, then in that case, photons will be amplified through a cavity which has been existing in this APD, and that cavity is said to be amplified resonating cavity. All this will come in the case of lasers. And finally, the last block here is said to be electrical receive, and this electrical receive is again the reverse of this electrical transmit. So this electrical transmit is said to be the drive circuitry to this optical source, whereas to the optical detector, drive circuitry is said to be electrical receive. What this electrical transmit has done, it has converted low frequency electrical signals into high frequency electrical signals, and this electrical receive is going to convert the high frequency electrical signals into low frequency electrical signals, because it has given electrical signal as the output. Therefore, those have got higher frequencies, and our human ears cannot able to understand these high frequencies. So for that sake, we need to use this electrical receive, which is going to convert a high frequency electrical signals into the low frequency electrical signals. So this is said to be the simple concept regarding the optical fiber communication system block diagram. So so many times this question has appeared in your external question paper. So this is the simple concept. Therefore, you just focus more on this topic. So in the next video lecture, what we do is we just discuss the advantages of this optical fiber cable. So I know that you people are aware of the advantages of this optical fiber cable to some extent. So during the introduction only, I just have said the biggest advantage that this optical fiber cable is been providing, and that biggest advantage is set to be the bandwidth. And similarly, I have taken one law. That law is said to be Shannon-Hartley law, indicating the relation between the channel bandwidth and the channel capacity. And that equation is C is equals to B into log 1 plus signal to the noise ratio to the base 2. So C and B, both of these are directly proportional. This is what I just want to discuss in the next video lecture.